We were at a trig 8, right? If you have any questions of anything, anything from the handout, okay, so feel free to bring them up. So trig 8, yesterday we covered the first example. Did you guys try the others?
Yeah. But
Got it?
after number 6, it got pretty hard.
I could hardly hear you. Could you make it louder?
When it got to number 6, it got really hard.
Did you say number 6?
Yeah.
Yeah, I had trouble with those too, actually.
This is double angle, right? Yeah, is that double angle?
And it has a 2 arc cosine x. So it's 2 in the front.
Okay, solution. So we understand how it works, right? The input is a ratio. Ratio give it our cosine. Our cosine work on this ratio and then double the angle. So this arc cosine is an angle. And this angle is going to be, this angle is going to be where? First quadrant or second quadrant, right? That's the range of arc cosine, right? The range of arc cosine. Before the beginning of the class, I bring up these, all these things we have learned and summarized, right? Sine, arc sine, and cosine, arc cosine that we have done, and tangent, arc tangent. Okay, all of these things I put it near us or near my cursor is just to emphasize the fact that all of these may be used, and in addition to that, you guys have in trigonometry you have learned double angle, sum of angles and so on and so forth, right? So this is the moment. Okay, so this guy will turn into sine of 2 times theta. So what is it? Do you have any idea about double angle formula?
It sounds pretty familiar, but I don't exactly remember.
It's in the handout. Okay, I don't know which page is this in your handout because I'm using this older version of it. But at the back, I think it should be. I also put it in the at the back of the handout. So you go to the very back. I was trying to make it convenient to wait. In the back, is it in the back? Yes. The second to the last page. You also see those formula. Okay. Do you guys see that?
So then, if I remember correctly, you would cancel it out because it becomes 2 sine A and cosine A, right? Or am I wrong?
So, could you say it again?
So that would become 2 sine A 2 sine theta and cosine theta, right?
That's right. Okay. These formula, okay, I put it in such a way that it also indicate how they're being derived. there are some, I have some old videos that all the recordings about how they're being derived if you don't want to memorize them, which I highly recommend. They're available in the module. Okay. These are the formulas. These are important tools you have learned in trigonometry, didn't you? So let me show you where you would find them. I would encourage you guys to. This is this looks like the formula sheet. Yeah, this one here. Do you guys see the formula sheet here? Yeah.
Yeah.
This is in your handout. This is in your handout. It's the second to the last page. And this formula is also a chart. Okay,
You don't see what you're saying. We see your emails. It's frozen, I think.
Oh. Hold on. Then move it over. There. Do you see this one? All right. Yeah. So this is the formula sheet that you should see in your second to last page of the notes. Okay. Let me show you. There's another place that you can find it easily. Go to your module. Trig formula diagram. Okay, trig formula diagram right here. Do you see that?
Yeah.
This is the trig formula in your diagram. Do you guys see that? Yep. Right here. Okay, click on it. Okay, there's a PDF file of that page of formula. As I said that this class is 5 classes in one. This class is 5 classes in one. Which 5 classes? Trigonometry, college algebra, intermediate algebra, beginning algebra, pre-algebra. 5 classes in one. Okay. So it's impossible we go into every details in every one of those courses, as you understand. A lot of the things you have to study yourself, but I have made available, I prepare some materials, and this is one of those. Okay, if you click on this diagram, okay, this is a diagram. Do you guys see that? Do you see this diagram? Yeah?
Yep.
Okay. On this diagram, okay, so let me, why this one is here. Okay, but anyway, do you see this diagram, right? This diagram is not just a list of formula. It's just not just a list of formula. It also tells you that all of these formula are derived. All of these formula are derived from here. Okay. This is the place it's all started. Okay, if you were in my trigonometry class, I believe we derived some of those, didn't we? Okay. And then these arrows shows you how to go from here to the next place. For example, from this formula, you will do something, you do some substitution here, and you get to the next one. From this formula, okay, from this same formula, you do something on left or right, you get this formula. Okay, and from these two, okay, from these two, okay, you do add additional subtraction, you get these two. Okay, and from these two, you do addition, subtraction, you do addition or subtraction, you get these two. Okay, of course, all these operations were given to you. All right. If we have time, I can go through this in class, but there are already postings of the past recordings for you, just in case we cannot do it in class. Okay. And the way I talk about these, how to derive them, and they're very similar to, you know, how I conduct the classes. So in the other direction, okay, in the other direction, you can see everything on this side derived from here. Okay, you go that way, this way, you get these, all of the formula. Okay, now, well, all these essential formulae that you're going to see. Okay, and these formula also typically listed in the textbook, or in the calculus textbook. Okay, some of them, you know, well, probably all of them are going to be very useful. But anyway, in the other direction, so from here, right? If you, this is the operation. Oh, hold on, I'm using the wrong. Okay, so if you make this substitution, okay, make this substitution, this guy will turn into double angle for sine. And this will turn into double angle for cosine. And from here, of course, so all these arrows are very concise. They've been test drive. You know, I made this chart. It's been test driven many times. I went over this with my classes when I have a chance. Okay, but every semester is different. Every semester is different. So we may or may not have time, but I highly encourage you. So if you just use this chart, you can find your double angle right here. Okay, there's double angle right there, and double angle for cosine. Okay, in this chart we don't have the double angle for tangent or cotangent because it would not be necessary. You can just derive it yourself. Okay, the main emphasis I have here is for you to derive it yourself, well, which is highly recommended. Okay, because if you do, you never have to remember any formula. They're all going to be in your head. Okay, even if you don't remember them, and when you need them, you know how to derive them. You can just quickly derive them very easily in the moments of your need. I cannot emphasize enough about this deriving ability, and this will also enhance your algebraic ability. Okay, we know that algebraic ability is essential for your success in calculus classes. Okay, and so this is the chart, and of course these are the half angle. Then you know from here, half angle is also, you know, this is already indicated. It's from here. Okay, but anyway, without further ado, so you know where to find the formula, don't you? Okay. Next, how to derive them? How are they derived? Okay. So let me show you that. Trig formula. Right, so you go to module. You go to module. In module, syllabus, office hours, homework, trig formula diagram, and these are the past recordings. Okay, past recordings about deriving trig formula. Okay, deriving all of these is about deriving that. If you haven't derived it yourself, I highly, highly recommend it. Highly, highly recommend it. In the past, I always said the same thing to my other classes, whether I taught pre-calculus or trigonometry. I told the student, you should derive them. You should derive them. Please, you should derive them. It's good for you. How many people actually do that? I think not very many. Not very many. Okay, but those who did it, they came back, tell me how helpful that was for them. It's your choice. It's your choice. Okay, so it's entirely your choice. Now, go down this list, special triangle and unit circle, sine, arc, sine, arc, sine examples, and all of these sections right here. This entire section is about trig review. Okay, I personally wrote them up so they will match my class. They will match my classes. Okay, and you can compensate that with textbook. Okay, you can compensate that with your textbook when you're reading them, when you read them. You read these sections. Now, with that said and done, okay, all of these are condensed into here. Okay, all of these, sine, arc sine, cosine, arc cosine. Okay, those tables we made in class, and tangent, arc tangent. So all those sections, they are to illustrate from, you know, in writing about these processes. Of course, in class, we actually cover the material in even more details, but reading those and, you know, watch the lectures, and I think it's would be very, very helpful for you. Okay, so without further ado, let's come back to number 6 of trig 8. Do you think you will have a clue? Okay. So the tools you use, okay, they're all here. They're all here. Okay. And the other one, of course, is definition, ARD. The other one is the ARD. That's really all you need. We have covered all of it. And the essential part. And this piece here is to remind you of ARD. All of these tools, okay? They all are from the definition. They are all from the definition. So when we handle this question, okay, and we need to understand that cosine theta is equals to x, right? So we have, in order to find the algebraic expression for a sine of 2 times arc sine x. And with this assumption, because we know this is an angle, right? This is an angle. Do I need to explain this, why this is an angle? Does everybody get it? Okay. You understand is a cosine takes angle, produces ratio. Arc cosine takes ratio, produces angle. An angle is in a specific range, right? Domain range. This is all of that stuff, right? Okay, so this will be equals to sine theta multiply cosine theta. We already know cosine theta. We just have to find sine theta. Okay, we just have to find sine theta. So how do we find cosine? How do we find sine theta from cosine theta? We go from definition. We go from definition. But arc sine, I'm sorry, arc cosine, the range is from 0 to pi. And therefore, you don't need these two quadrants, right? So we don't know where theta, we don't know where theta is. We don't, right? But we do know that theta is either terminate in the first quadrant or the second quadrant. In either quadrant, sine is positive, right? Cosine is positive, negative, but sine is positive. So from this condition, okay, from this assumption, okay, from this assumption, that's not necessary. Okay, so from this highlight assumption, and over here, cosine theta equals to x, right? So we would know that this is theta. And of course, it could be the other one is theta. Either one could be the theta, right? That's the A. ARD, that's the A, yeah? So this theta here could terminate either in the first quadrant or second quadrant. And there's no other possibilities because it's the theta is a consequence or in the range of arc cosine. In either interval, in either quadrant, if you draw a triangle, okay, this is a R, okay, reference angle, right? Cosine theta would be what? Adjacent sides over hypotenuse, right? Adjacent sides over hypotenuse. So the adjacent side will be what? This one? Hypotenuse. And what is this side? What is this side? What is this side?
Y.
What does this side equals to? In either case. Right? This is 1. And what is this side?
Root 1 minus x squared.
1 minus x squared?
Root 1 minus x squared.
Square root of 1 minus x squared. Okay, so this side, does everybody follow me? You can see that the domain and range is so important. Do you see that? So we'll be emphasizing all along. We know the reason, right? So this side, okay, is 1 minus x squared. And then you just plug in. Then you just plug in. 2 times sine theta. That's 1 minus x squared. Okay. And cosine theta is x. Okay. I would write it as 2 times x square root of 1 minus x squared. Is that clear?
How did you go from sine 2 theta to 2 sine theta cosine theta? I missed that part.
How did I go from what?
Sine 2 theta to 2 sine theta cosine theta. How did you get to there?
Can someone else answer that question?
If you look at the chart that you showed us,
The formula chart.
yeah, the identity, if you look at the top right, it would say that sine 2a is equal to sine 2a cosine a.
Tell him where to find it. You go to the module in Canvas. Okay. Go down the list in module. The first one is syllabus, second one, office hours, third is homework. The fourth one, Trig review. The top button on the Trig review.
The trig formula PDF.
That's right.
Yeah, I have it open. Thank you.
Any other questions?
So I'm confused about the where you take the root 1 minus x squared and then so you just replace it with sine theta and cosine theta.
Sine theta is opposite over hypotenuse, right?
Mhm.
Hypotenuse is 1. Isn't that equals to x over 1,
Yeah.
right? And that's adjacent sides. And that's the hypotenuse. Yes, adjacent side is x, the hypotenuse is 1.
Mhm. Oh,
Yeah.
I see what you did. Okay.
It's a ratio, right? It's a ratio.
So then you took the x because it's the adjacent and then you replaced it with the cosine and then you
The
multiply.
adjacent sides is x right here. This
Oh.
angle is adjacent sides.
Okay, I got it. Thank you.
Okay. All right. How about we do this? How about we do this? Okay. I'm going to remove the share. Okay. You guys are going to do this question all over again by yourself. How about that? I give you 5 minutes. I'll give you 5 minutes. Everybody get your paper, pencil. Okay. Everybody get your paper, pencil. Work on number 6. Work on number 6, please. We have 16 people on the participant. Let's see. Chat. Everyone works on number 6 in Trig 8. Okay, see if you can do it. There's no pressure whatsoever. Try not to look at the notes. Just follow. Just try to work on it. And in the process, you are going to identify where you were lost. That's what I hope for. So I can help you with that. Ready? Right, guys. You know, this exercise, while doing this exercise, I actually want to make a point. Okay, we don't always do this, right? I did something on the board and then I put it away and asked you guys to do it again. This is something I want to talk to you about as well, that a lot of time, I guess I get people ask, how do I study? How do I study? How do you study? Anybody would contribute some method of your study? You do homework? So right after class, you do homework, practice tests without notes? Well, thank you for your contribution. Okay. When I was in college, at the beginning, okay, writing out the notes you sent, very good contribution, very good contribution. So did you guys see the comments? Homework, practice test without notes, try it, and if you're stuck, ask for help. Writing out the notes you sent. Okay, thank you for your comments. Do you guys see me? Okay. When I went to college, and the first year was quite a struggle. The first year was quite a struggle. Did I tell you I was the first generation of my family to go to college? Did I tell you that? Now you know. I was the first generation. I have a brother, I was the older one, and so I went to college. The first semester, it was quite a struggle because it was a transition from trigonometry to calculus. Okay, we didn't have a class called pre-calculus, so there's no review. So we jumped straight from trigonometry to calculus classes. It was really, really a struggle. Just like what you said, right? You after class, you're gonna do homework, and you do all of that stuff. And so after the classes, and you trust I was a very diligent student, okay? And I didn't have much distraction at the time, and I was young, and I was no dating, no movies, right? So our life was very, very much focused on the academics. As a matter of fact, at that time, dating was not allowed. So no dating. But anyway, after the classes, I will go to the library and study. And of course, I will hit the homework straight. And then I realized I cannot do a lot of the homework questions. I cannot do a lot of them. And then I said, what am I going to do, right? I thought I understood the lecture, right? In class, I took notes, and I thought I understood every proof of the theorems. I was a math major, of course, right? So all we did, we proved a lot of theorems, theorem after theorems, and I thought I understood. So I hit the homework straight. And guess what? I cannot do most of them. And later, I figured out a different study method, which works for me, which is not hitting homework directly. Okay? Or not to try to do the practice test directly, is to study the lecture all over again. Okay? And I found that immensely helpful for me. So basically, after the class, you know, I have the notes, I have the textbook, I even have several, you know, reference books I can borrow from the library. And I go through the lectures the professor went through in class in every possible detail. Because every possible detail in the class is a concentrated form of study, okay? Every sentence, everything you write it down on the board is essential for you doing homework. After I have adopted this new method, my grades just improve. And I'm feeling much more comfortable with what I'm doing. Because when you hit homework directly, you're trying to really, you know, I would say, I will use a metaphor. It's more like you're trying to make a tiger out of cat. Right? You try to just copy and paste and just change the numbers and change the functions. That's not the way to go. You don't understand. You see, in the classroom, I thought I understood. And I hit the homework. It didn't work. You have to go back to study the lecture from beginning to end. If possible, you will put away your notes, you put away your lecture to try to do yourself. So this exercise I just give you to try to let you see that I just did it. And you do it immediately, close book, close notes. I don't know, you know, if all of you are doing that. But it's up to you. I'm just saying from my own experience, when I see an example went over by my professor in class, after class, I close the book, close notes. Guess what? I cannot reproduce. I cannot reproduce. I'm not saying about you. I don't know about you. I think you probably, you know, if you can reproduce right away and understood every step, and they can, better yet, you can explain to someone every step, then you are a genius. You don't need to be in my class. How many of you can do that? Can you give me some kind of private message? You can do that? Just for this little exercise. How many of you did it? What does that tell you? We talk about learning from our own experience, right? We're talking about learning from our own experience. From the response I had, from the question I had in this class, I knew most of you did not go over my lectures after class. I knew it. Am I right? You know, God knows. That way, let me tell you, it's not going to work. That study method is not going to be work. It's not going to work for you. You're going to be forever struggling. Okay, you're going to be forever struggling in mathematics as long as you're in college. Are you going to find another way? Well, it's up to you. It's up to you. I'm just telling you my way. Okay, so I use this method I learned from my own experience, and I finished all my math courses with very good grades. So that's my study method. That's my study method. It works for me. It really worked for me. On top of that, okay, I have gained a lot of confidence because I know what I'm talking about. I'm not just trying to draw a tiger out of a cat. Okay, so there's no secret. Really, there's no secret. It's not because I'm smarter. No, I'm not smarter. I'm just as smarter. I'm just as smart as you are, and you are probably smarter than I. But I adopted this systematic way of study. Every, let me summarize. Every class after class, I went through the classes. What's been covered in class? I go through every little details, every little thing my professor mentioned in class. I try to write it down, and I try to make sure I understand every single point. And when I hit the homework, easy. Easy. If you don't do this, okay, if you continue to do what you do without adopting, at least try my way of doing it, you are going to struggle in calculus classes throughout. I guarantee you. I guarantee you. Do you follow me? Because as a teacher, as a professor, we prepare for our classes. In our classes, we cannot allow to get stuck for 10 minutes. So all the stuck and all the hardship we solve these questions in my younger years, they're not going to be showing up in the lecture. But for people who learn it, you're gonna have hiccups at different steps. And those hiccups at different steps, only you can remove them. Nobody else can remove them for you. You have to do this work to get through it. If you don't go through that process and you want to hit the homework, you're gonna have the same hiccups, and it's not gonna work. And that's why you have so much hardship with homework. Do you follow me? So I personally, I'm very happy to do questions, work out these problems with you. But if you don't do that due diligence yourself, don't do that study yourself, you forever have to ask questions. To me, that's a loss of independence. All right, so that was my, my sidekick on how to study. It's easy to do, and it is easy not to do. Because sometimes we feel, oh, I don't have time. I gotta hit the homework. I gotta get it done. Well, the homework is just to support your understanding of the materials presented in class. Let me say it again. The homework is to support the understanding of the materials presented in class. So what is the important part? The important part is understanding the lecture. And homework is to test drive if you understand the lecture. Do you understand what I mean? The lecture is the centerpiece. The homework is just a supplementary. You follow me? You essentially will need these materials, right? We'll need these materials, domain and range for your whatever. I hope what I shared with you will be helpful. At least you make you think about, reflect on the method of your study, how to make it more efficient, right? We all have this limited amount of time. Thank you. Okay, we all have a limited amount of time. You have to reflect on these methods, which way works, which way doesn't work. The way that worked for me, it certainly was not a shortcut. And let me tell you, I have not found a shortcut. I personally have not found a shortcut. So I can say maybe there's no shortcut. Did I meet people in my early years, in my college years, that those students, they're super smart than I? Yes, I have met those. I met some of those people. They're very smart. But you know what? Too bad. I'm not as smart. So I have to do that hard way. Okay, so if you're super smart, I recommend you should not take my class, because I assume everybody is just as smart or just a little bit smarter than I, but not a super smart. You follow me? Let me tell you this story. Years ago, when I was in college, I was, you know, we were doing well, and I was either number one or number two, number one, number two, right? Sometimes I get to number two place, and the guy who was, I thought he was really smart. I thought he was really smart, and I always wish I was just as smart as he was. And about 30 years later, we met again. I was asking him, how come he was so smart? He said he forgot everything already. He seemed to have some kind of different ability to do well, which he didn't have to spend as much time as I did. And then he said he learned fast and he forget fast. So I kind of resolved my unfinished business in that way. Because when I felt like, you know, I'm just so dumb, I just have to do this way, is sometimes is not a terribly good feeling, right? I just kind of feel stupid. I feel stupid all the time. I have to tell you the truth. Okay, that's my personal thing. I feel stupid all the time when I was in college. But I work hard. I work very hard. And that's how I made it. That's how I made it. First generation, I got no help with my parents. I got no help, then there's no tutors. We cannot afford tutors. And it was very competitive. It was very, very competitive. How did I make it? Hard work. So I developed this systematic way of doing it, and it worked for me. And I graduated, you know, pretty much top of the class. I didn't ace every class though, by the way. I did not ace every class, but I aced most of the classes. And I hope that story tells you, helps you at least to reflect on your current way of study, and you develop a new way that works for you, okay? Anyway, without further ado, how much time did that take? That takes quite a lot of time, okay? Thank you for your patience listening that. All right, so did you get it? Okay, I'm gonna continue as this, okay? When you study professor's lecture, after class, you are bound to get stuck somewhere. Okay, you should not be surprised. You are bound to be stuck somewhere because you may miss something, or the professor forget to mention a specific reason. And how do you do it? For example, in these steps, where did you get stuck? When you do it again, tell me, where did you get stuck? Would you share with us where you get stuck?
I just forgot the formulae. I thought that I just completely forgot about them.
But that's okay. Isn't that nice to discover, you actually forgot the definition. This is really the definition, right? The D. How many of you got stuck here? When you do math, every stroke you write down has implications. Do you believe me? Every stroke I wrote down has implications. All of these work seems nice, It's okay, right? It's not a beautiful painting, but it's a pretty neat work, right? Every piece of neat work behind it. Okay, just like you watch Michael Jordan throw the basket, right? Or who else? The guy who recently passed, who was gosh, I forgot his name. How could I?
Kobe Bryant.
Say it again.
Kobe Bryant.
Yes, Brian. Those shots he get, right? How many practice do you think he had behind the scenes? In math, I promise you, you don't have to do that much. I promise you, you don't have to do as much as Kobe Bryant as he practiced his, basketball. And you will get it probably halfway practicing that. What I meant here that for each one of these steps, there's a scratch paper next to it. Okay, there's scratching all over. You maybe throw away a page. Oh, this doesn't work. I'm gonna try again. Second page, scratch paper. Third page of scratch paper. That's a Kobe Bryant shooting basket in his backyard. 1,000 times. There's a practice behind it. So that's how the lecture is made of. Every single step is my years of study. I'm much older than you, right? Right? I'm probably your mother's generation. So does that tell you it's worth your while to restudy the lecture? Tell me, is it worth your while to restudy the lecture?
Yeah.
But I
definitely.
promise you, I did not have to make that many shoes as a Kobe. That's a good news, isn't it? If you do just as many, shoots as the Kobe, you probably will make yourself a famous mathematician or a PhD in mathematics. They say, hey, I don't want to be PhD in mathematics. I just want to get by. I want to get a degree in CS or whatever, computer science or mechanical engineering, a master's degree or bachelor degree. I'm going to find a decent job. You don't have to do this. You don't have to do as many shoots as a Kobe Bryant. Does that make sense to you? That's how much work is behind it. All right, so I hope that gave you enough reason to study the lecture all over again. Okay. Anyway, without further ado, so let's try another one. What I proposed, okay, my method of study is, it works, well, everyone can do it. You can modify along the way, but I think the essential part is to study the lecture. Right? I don't know if there's a saying that if you perform on the stage for 10 minutes, that's 10 years of practice. Is there such a saying? If you perform on stage for 10 minutes, that's 10 years of practice. And I totally agree with you, or with that as a sentiment. Okay. But on the brighter side, I also wish to tell you, there's another comments I heard some years ago by a student. A student say, oh, you look at that professor, she can do what she does because she does it every day. For the past 30 years or 20 or 50 years or whatever. That's not true. That is not true. Okay. I spent 4 years in college. All I learned here, okay, that 4 years, I have learned, you know, of course, prior to that, I was in high school and I learned those, you know, algebra stuff. Total, suppose 8 years. Suppose 8 years to study mathematics. After I graduated, you know, with my degrees, whatever, I did not have to practice every day. So what I meant here is that you just concentrate your young years. If you think this is something you have to do, you want to do, you must do for 4 or 5 years, 2, 3 years, it's up to you, right? And you will get over it. You don't have to do it for the rest of your life. Do you follow me? After I graduated, I got married, I had children, I raised my children, and they have graduated from college, and here I am. And along the way, I didn't have to learn this. I don't have to do this every year. It's all inside of me already. So what I'm telling you is it is possible for you to devote 3 to 4 years of your life to get your degree in STEM and to find a decent job. And then from that point on, you start to enjoy your life and accumulate your wealth. Do you follow me? You're gonna make much more than I do. I know most of you don't want to be a teacher, right? Teachers don't make much. You don't have to be doing this for the rest of your life. Just 3, 4 years. And you're set. You're all set. Okay. Ooh, that was too long. Let's try another one. Let's try another one. Shall we? Would you like to try number 8? That was too long a speech, wasn't it? Right? Wasn't it? You don't have to do this forever. I'm actually trying to give you some sense of simplicity and summary kind of study. Okay? Because I know you don't want to be like, you don't want to be me, right? So 2 times arc sine. Do you want to try that?
Yes.
You recognize this is going to be an angle, right? This is going to be an angle. Okay. So we'll do similar things. Okay. Arc sine x equals theta. You can say let, right? Then you say, well, where does theta belong? What can theta be? And that will be given by the range of arc sine. What is the range of arc sine?
Negative pi over 2 to pi over 2.
That's right. Very good answer. Thank you, Mikhail. Okay. So you know the terminal of this angle is either in the first quadrant or the fourth quadrant, right? Either the first or the fourth. So we know that sine theta is equals to x, right? And you can think of the definition is x over 1, right? It's the opposite side over hypotenuse, right? But you don't need to show this. No need to show. Okay. And then you, of course, you always have ARD in your head. Always, always. When you do trigonometry, it's all about ARD. It's all about ARD. Okay. So in your terminals, right here, no terminal. Right? Does that look familiar? We done this when we do the arc sine, we did that, right? So your terminal will be where? Either here or there. Okay, so this could be your theta. And or this could be your theta. Either one. We don't know which one, right? And then what? It tells us that sine theta equals to x. What does that mean? If it's in this quadrant, right? That's the opposite, that's the adjacent side. If we're in this side, if it's on this side, on this piece, and that will be the x, and that's the hypotenuse. You follow me? And what do we want to find in the end? We wanted, what do we want? Okay, so that makes this like think out loud. Okay, I will show you a piece of work that's now right now I'm treating this as a scratch paper. Okay, right now I'm treating this as scratch paper. Okay, so what is wanted is tangent 2 times of arc sine x. And what do we do? And that's the tangent of 2 times theta. And then you look at the diagram, there's no formula there. What do? You derive it. You derive it. Okay. And then you go, then you start derive. Tangent 2 theta equals to sine 2 times theta over cosine 2 theta. Okay. And you're going to find out, and this equals to 2 times tangent theta over 1 minus tangent square theta. When you derive that, you should be able to. You should be able to. Then you say, oh, I cannot, not yet. Okay, go back to practice. That's the whole point of pre-calculus class. It's to review everything you have learned up to that point and prepare you strongly for calculus classes. Okay, so let's derive this together. Are you ready? And after I'm done, you're gonna get your turn, okay? We're gonna practice this study method again. Now, what is sine theta? It's 2 times sine theta cosine theta. The bottom, you know the double angle formula, don't we? Is this too small for you guys to see? Can you guys see that on your screen well?
It's kind of too small. Can you zoom in?
Certainly, that's what I'm asking. How about that? Is it better? Is that better?
For me, it is.
For me also.
Is this size of font okay with you? Okay, I see it's good. Okay. Sine 2 theta has a formula in the chart, right? Cosine 2 theta, there's 3 formula for cosine theta. There's 3 formula for cosine theta. You can use any one of them. You can use any one of them. Okay. So suppose I'm using cosine square theta minus sine square theta. I'm going to make it even larger, okay, for you. Is that better? On this one, I'm going to divide on the numerator, denominator, by cosine square theta. Does everybody follow me? Can you space them out more? What do we get here then? Cosine square theta, cosine theta. So one of them is gone. Cosine square theta divided by cosine square theta, that's 1. Sine square theta over cosine square theta, that's cosine squared theta divided by sine squared theta divided by cosine squared theta. And that one is squared. So in the end, you get that. Frankly, I wish to tell you, by the time you are in calculus class, you are expected to be able to do this when needed. Deriving, these are considered pretty simple deriving. Because when you're taking trigonometry class, there are lots of deriving going on. And these techniques is being used over and over again in trigonometry class. Okay, and all of these work is on your scratch paper. Okay, see, I have the scratch paper right here, right? So I'm working on this. I'm still working on the scratch paper, right? So I have derived over here, right? This formula. So where am I now? This is wanted, right? And I have this formula derived. If I go back to what I know, I can find sine theta. From sine theta, I can find cosine theta, can I? If I have sine theta, I have a cosine theta, can I find tangent theta? Sure. Okay. So now, what is a cosine theta? So terminal in the first quadrant or the last quadrant, quadrant number 4, and this is theta, right? And this is the triangle, and this is the x, and this is the 1. How do we find cosine theta? Cosine theta is this side, right? Okay. Now, this side is going to be, we did this earlier, right? 1 minus x squared. So this is sine theta, this is cosine theta. Sine theta divided by cosine theta is tangent theta. And then once you find tangent theta, you plug in here. So tangent theta, plug in here. Plug in there, then we're done. Do you guys get the idea how to finish? So you need to have that scratch paper to work on it. And then it's time to organize our work. Does everybody follow me? Does everybody follow me? Okay, so now I'm going to put my work together and turn it in. Okay. Did you write it down? Everybody? Okay, so now I'm going to compose my solution. Your solution, that's the first part. Okay, you may want to bring this picture into your work, but it's not terribly necessary. Okay, it's really optional. It's really optional. So I'm going to put this picture just on the side. Okay, hold on. I'm going to put it over here. Okay, for now. And I'll be telling the reader that, okay, if that's the case, cosine theta is equal to the square root of 1 minus x squared. As a result, tangent theta is equal to sine theta over cosine theta equals to that. Okay? And then you say, excuse me. Thus, tangent 2 times arc sine x is equal to tangent 2 times theta. And tangent 2 times theta is equals to that formula. Okay, I'm going to take that formula over here. Does everybody follow me? Equals to, now you plug in 2 times tangent theta 1 minus simplify. Okay, simplify. And so this will be 2 times x, 2x over here. This square is going to go to x squared. This is gone. And this root will be gone. Simplify next, okay? These words are for lecture use only. You don't need to use these words. Okay, I'm just telling you what I'm doing here. And then you're going to find common denominator. This is a complex fraction, right? You learn complex fraction in probably intermediate algebra. So from now on, I'm going to write it horizontally. Okay? So how do you simplify this? You're going to multiply 1 minus x squared on top, 1 minus x squared in the bottom. On the top, you multiply that. Okay, just remember, okay, x here, this x is from the domain. X is from the domain of arcsine. What is domain of arcsine?
Negative pi over 2 to pi over 2.
Domain of arcsine is negative pi over 2 to pi over 2.
It's 1. It's negative 1 and 1.
That's right. Okay. Domain of arcsine is from negative 1 to positive 1. Okay. I.e., the absolute value of x is less than or equals to 1, or negative 1 less than or equals to x less than or equals to positive 1. All these forms we have to be, we have been using them, right? With that understanding, of course, you assume this is not going to be 0, right? This is not going to be 0. So all of these you need to consider. So the reason I mentioned x is between negative 1 and 1 is because you want to relate to that. This parentheses squared. So that way, when you simplify the top, right, you're going to end up with 2x multiply root of that. Because this is squared, this is not squared, so these are reduced. So you have the top. The bottom, what do you get on the bottom? This guy multiplied by 1. So you have 1 minus x squared and minus another x squared. So in the end, you combine the like terms. That's the answer. All of these algebra, which run through trigonometry algebra classes, basic algebra, elementary algebra, the intermediate algebra. And you are expected to be able to do it because in your calculus classes, you're going to be deriving all day long. Product rule, quotient rule, chain rule. You just name it. Lots of deriving. Lots of deriving. So you must work very, very hard. If you miss some bits and pieces in the past from those 5 classes, this is your last chance to make up. Otherwise, you're going to struggle horridly in calculus classes. Right now, we're in, pandemics study mode, right? We're in pandemic study mode. Normally, if we were on campus, there's a little corner on the first floor in Math and Science building. There's some board, okay? And sometimes a lot of students are working in that area. They cover the board with mathematical formula. Guess what classes they're studying? They're studying calculus classes. And from time to time, some of the professors in math department, they will show up there and lead the discussion and write down those, deriving and stuff. I mean, these little deriving, it's really just the peanuts. Okay, you are expected to be able to do. Okay, so keep on deriving. Okay, so can you guys see this whole thing? Do you want to do it yourself? We don't have time to do it in class then. You do it after class. Okay, you do it after class for your own benefit, Okay. So far so good? But on the hand side, I wish to tell you, every one of you can do it. You may get intimidated or, you know, feel insecure at the beginning, but soon enough, you realize you can do it. If you can, you must. Okay, so keep on deriving. Okay, the class is about coming to an end. So I'm going to just give you some words of encouragement. Okay, keep on deriving. Don't drink and derive. Okay, and you can do it. You can do it. You can totally do it. If I can, anybody can. Right? Did I tell you my humble? I've told you my humble beginning. If I can, anybody can. And I promise you don't have to do this forever. Okay, just maybe 3-4 years of your life. If you think your academics worth you 3-4 years, and then you start a fabulous career, well, if that's your choice, that's your choice. Okay, and you suppose you don't have $1 million to inherit, right? If you have $1 million to inherit, then you don't have to be here. Yeah, anybody has? Yeah. I wish to know you.
No.
No, not yet. Not yet. I inherited nothing from my parents, but their love. Yeah, most of us don't, right? Most of us, we're just common folks, right? I wish, but I don't wish. Okay. You will enjoy the fruit of your own labor so much more than it's being handed to you. Don't you think? Sometimes we enjoy our own fruit of labor much more, and we appreciate it much more. Because along the way, you realize you have that ability to do it. You have that ability to do it. You know, there's some people who have enormous wealth and they don't have to work. Sometimes they have their fair share of psychological problems, right? But anyway, I'm not going to dive into that kind of discussion. That's not my area of expertise. But I think if we're meant to do this, we may just do it well. Yeah, we just do it well. And I'm here to help you. I'm here to help you. Okay. And once again, I share my own experience with you. But that's all I can. That's all I can do. Okay. And I hope to make it simpler to you, easier to you, but not without effort. I'm not showing you a way without any effort. It requires a lot of effort. All right. Anyway, without further ado, I will encourage you guys to continue deriving. There will not be new homework assigned to you. But just keep on doing the existing homework, and I will send you a quiz today. You will have a quiz today. And but if you have any questions, please don't hesitate to ask me. Okay. I will jump into my office hours after this, and everyone is welcome. So long.
Bye.
It's been a pleasure.
Thank you, Ms. Chang.
Of course.